Assalamu alaikum everyone, I hope you guys are doing well. So in this video, we will be looking at the two categories that we haven't covered so far. That is category 2 and category 3 of forces, and that is coplanar forces. So category 2 is where you have 3 or more forces, and category 3 is where you have 3 or more forces in equilibrium. Now we have learned the basic concept, which is how to break down a force or resolve a force into X and Y components if it is not horizontal or vertical. So there's nothing essentially that's new in these categories. It's just that you will notice that the questions have gotten slightly more complex and there's a lot of working required in order to get the final answer. So we will straight away jump to past paper questions because like I said, there's nothing conceptually here for us to learn. And I will make sure that I attach this PDF in the description, so that way you will have my notes and also solutions to these questions that I'm going to solve. Okay, now let's get straight into it. This is a past paper question and it's fairly recent as well. No, not that recent, but yeah, May, June 2019, paper 4, variant 3. Okay, so let's have a look at what the question is saying and let's break the question down so that it's easy for us to solve. So it says here, coplanar forces of magnitudes 12 Newton, 24 Newtons, and 30 Newtons act at a point in the directions shown in the diagram. Okay, so have a look at the forces as well. Find the components of the resultant of the three forces in the X direction and in the Y direction. So here we need to write it down in the X direction. So this is a fairly easy question and it's a very nice question because it's sort of breaking things down for you. Normally it would just ask you to find the resultant and that's it. And then you would have to sort of break it down yourself. But, this makes it easy and it makes it nice, basically. So let's start by resolving this 24 Newton force. Now, bear in mind that we are first going to resolve for the component in the X direction, which means all the horizontal forces. So I'll color code it. This 24 Newton force will have a horizontal component and a vertical component. Now the horizontal component will be acting rightwards, the vertical component will be acting downwards. Okay, so since we are at the moment focusing on just the X component, so remember the resultant in the X direction will basically be all the forces acting rightwards minus all the forces that are acting leftwards. Okay, so since this force is acting rightwards, so we can write that down. So the resultant in the X direction will be the force that's acting rightwards. Now what exactly is this force going to be? This force, because I'm talking about the adjacent side, so because it's adjacent, if you remember the shortcut, so this is going to be 24 into cos 25. So let's write that down, 24 cos 25. Now there is no other force which, if we break down, will have a horizontal component which is acting towards the right. So that's it. And we will talk about, let's write this down. We'll discuss it later. Let's write down the vertical component of this force as well, which is going to be 24 sine 25. But we don't need this right now, so we'll come back to it later. Now let's resolve the 12 Newton force, which will have a horizontal component in this direction and a vertical component in this direction. Okay, now, so if you notice, we don't have this angle over here. So is that a problem? Not really. We can work it out. That's not a big deal. So 180 minus 25 minus 90 will give us this angle, which is 65 degrees. Now, the vertical component, which is acting downwards, will be 12 sine 65, and the horizontal component, because it's the adjacent side, will be 12 cos 65. Now we pretty much have all we need in order to find out the resultant in the X direction. So it's just going to be 24 cos 25 minus 12 cos 65. And you can leave it like this. In fact, it's better that you actually evaluate this and see what the answer is. So that's what I'm going to do. So this is going to be 24 cos 25 minus 12 cos 65, which turns out to be 16.67. Now, because this is something that this value is such that we will use it later on, we might actually use it later on, in order to find out the direction of the resultant. So I will write it down. I will round this off, but I will also make sure that I actually write a value that is slightly more accurate than the rounded off answer, so that when we get to the resultant part where we have to use this value again, we don't use the rounded off value, we use the pre-rounded off value. So there you go. We now have the resultant in the X direction. Now the component in the Y direction. So that's again pretty simple. in order to find out the component, the resultant in the y direction. So what we'll do is we'll take the force that's acting upwards, since that's what's usually considered as positive, and from it we'll subtract the force that's acting downwards. Now if you notice, as far as the upward force is concerned, because this 30 newtons is acting vertically, how do I know that? You can see that there's a right angle over here, so that means this is going to be 30 straight away. And from it, we're going to subtract all the forces that are acting downwards. So downwards, we have two forces. One is the vertical component of this 24 Newton force. So that's going to be 24 sine 25, 24 sine 25. And there is another force, which is this one, and this is 12 sine 65. So 12, let me make some space here, sine 65. Okay, so let's work this out. 30 minus, again, just make sure you don't end up making a sign error or something. So 30 minus 24 sine 25 minus 12 sine 65 is equals to 8.98, which is the correct answer. So 8.9814. Again, just because I will need these values later on, so I will write the answer correct to 3 significant figures, but I have this value, which I will use later on in order to find out the resultant and the angle, if we're asked to, which we are. So it says here, hence find the resultant and hence find the direction of the resultant. Okay, now, so notice that what we have done is we have basically taken all these forces. How many forces do we have here? 3 forces, and we have found out the horizontal component of the resultant, or you can say the resultant in the x direction, the resultant in the y direction. Now we want, like, you can think of it as the grand resultant, as the overall resultant. Okay, so what we're going to do now is we're going to make a right angle triangle. Okay, so let's switch to a different color. So this is what we're looking at. So we have a force, and notice since the x and the y, the answers to the first part, since they're both positive, that means this is acting rightwards. Okay, and since this is also positive, that means this is acting upwards as well. Okay, so that means what we're looking at, actually this is an incorrect representation, so it's something like this. Let me draw this again. So we have a rightwards force, okay, which is 16.7. Let me write that down over here, 16.7. And then where this ends, we have an upward force, which is 8.98. Okay, and what we need to do is we need to find out the direction of the resultant. So this is the resultant where I'm making these double arrows. This might remind you of a head to tail rule. That's what it is essentially. What we need to do is we need to actually find out the direction. So this direction is what I'm marking, theta. Okay, now because it's a right angle triangle, that means we can use the trigonometric ratios, and that's exactly what I plan on doing. So we'll go with tan theta is equals to opposite, which is 8.9814, upon adjacent, which is 16.7, but that's the rounded off value, so we're going to go with 16.679. And then in order to find out theta, we will take tan inverse of it. So tan inverse of 8.9814 divided by 16.679. So we're looking at 28.3, which is the correct answer. But the thing is, if you leave it at that, chances are that you will only get 1 mark, because whenever you're writing down the direction, it has to be with reference to a certain force. So 28.3, again, if we leave it like that, we're not going to get full marks because we don't know 28.3 from the horizontal, or is it a bearing? You can either write the bearing, okay? And then if you're writing the bearing, make sure that you mention that this is the bearing, okay? Or because 28.3 is the angle that it's making from the 16.7 force, okay? Or you can say from Rx, the resultant in the x direction. So, and it's in a anti-clockwise direction. So 28.3 degrees anti-clockwise from the x direction. So this is what will get you full marks. If you just leave it at the angle, like I said, you will only get 1 mark. Okay, so that's that. How many marks was this question for? 4 plus 2, 6. And you will generally find questions like these of 6 marks. Okay. All right. Now, so here we have another past paper question. This is fairly recent, May, June 2021, paper 4, variant 2. Okay, now, So it says here, coplanar forces of magnitude 34 newtons, 30 newtons, and 26 newtons act at a point in the directions shown in the diagram. Given that sine alpha equals to 5 upon 13, now this may be something new for us, and sine theta is equals to 8 upon 17, find the magnitude and the direction of the resultant of the three forces. Okay, now, so this is straight away, you're asked to find out the magnitude and the direction. You're not asked to first break it down. You'll have to figure that out yourself. And you're also asked to find out the resultant. Okay, the direction. So first thing you want to do is, let's pay close attention to this. Sine alpha equals to 5 upon 13. Now, what does that mean? Sine alpha being equal to 5 upon 13. That means that you have, if you remember, you should, the trigonometric ratios. Sine theta equals to what? Equals to opposite over hypotenuse. So that means if you make a right angle triangle using these values, the opposite side will be 5 and the hypotenuse side will be 13. Now using Pythagoras theorem, the adjacent side will be 12. 13 squared minus 5 squared. Again, I expect you guys to know this very well. So take the square root of it, so you'll have 12. Now the thing is, again, try and stay a couple of steps ahead. You know that when you break this down into x and y components, you will have sine theta, cos theta, or maybe sine alpha, cos alpha, depending on the force that you're breaking down, okay? So what I'm going to do now is, I will not find out the value of alpha. Instead, because you have to use it as cos alpha and sine alpha, right? Sine alpha we know, but what if I want to use cos alpha? So cos alpha is, we know what cos is, right? It's adjacent over hypotenuse. So cos alpha is equals to 12 upon 13. So that means wherever I see cos alpha, I will replace it by 12 upon 13. Okay, this way you won't have to deal with a lot of decimals. You can find out the angle and then you can sort of take the cos of that angle if needed, but not recommended, especially when you have integer values, especially when you have such nice values in the sense where they're all integers, okay? Now, we will do the exact same thing for sine theta equals to 8 upon 17. I'll switch to a different color for that. Let me underline it. And yeah, we are going to make a 90-degree triangle. So here, since it's 8 upon 17, that means we're looking at a 90-degree triangle such that the opposite side is 8 and the hypotenuse is 17. And if I'm not wrong, the adjacent side should be 15. Yep, 225 square root of which is 15. So remember, if sine theta equals to 8 upon 17, then through a right angle triangle and through finding out the adjacent length, you know that cos theta is equals to 15 upon 17. Now this is something you should do immediately, okay? Now, then comes the real part. Then comes the part where we have to break this down into x and y components and sort of start getting ready for the resultant. Okay, so first let's break the forces down into horizontal. First, let's break the 34 Newton force down, okay? So you will have a component that's acting upwards, okay? And you will have a component that's acting leftwards. Now, the thing is, you might think that, hey, wait a minute, this is not how we usually break it down. We usually break it down like this. Now, there's nothing wrong with that, except that if you break it down like this, you will have to make sure that you use the complementary angle identity, yeah, which I'm pretty sure not a lot of you have memorized, okay? So try and break it down in such a way where it's easy for you to find out, where the angle is easily figure outable, okay? So I hope that makes sense to you. So yeah, now I can clearly see what this angle is, so that means I can clearly find out, I can clearly break down this horizontal component, which is going to be 34 sine theta. Now, if you remember, I said do not memorize that the horizontal component will always have cos in it and vertical component will always have sine in it. As you can see, that is not the case here, okay? And then you have the vertical component, which is going to be 34 cos theta. Why is that? That's because this is the adjacent length, okay? Now, this 30 Newton force, since it's horizontal, I know that because of this 90-degree triangle, 90-degree angle, not because it looks horizontal. We know that for sure. Okay, so that means we don't really need to break this down. It's a horizontal force of 30 newtons, and the vertical component of this force will be 0. Okay, now let's switch to a different color and let's break down this 26 Newton force. So just be systematic with your working, and whatever it is that you do on the diagram, make sure you do it in using a pencil so that if you mess it up, you can always erase it and do it again. Okay, so this is going to be 26 sine alpha, and because this is the adjacent side, this is going to be 26 cos alpha. Okay, now that we have sort of broken down everything. Now we're going to head towards solving this, okay? So if I want to find out the resultant in the x direction, that means I will find out all the forces acting rightwards, and from it, I will subtract the force or forces acting leftwards. Okay, so let's do just that. So how many forces do we have that are acting rightwards? Just the 130 Newton force, so 30. And from this, we're going to subtract these two forces that are acting leftwards. So that means 34 sine theta plus 26 sine alpha. And I'll explain in a minute what are we going to do with sine theta and sine alpha. Okay, so that's that. That is the resultant in the x direction. Okay, so 30 minus, now what is sine theta equal to? Sine theta, if you remember, it's right here. It's 8 upon 17. So into 8 upon 17 plus 26 into sine alpha. What's sine alpha equal to? That is 5 upon 13. Okay, so let's evaluate this and let's write this down. And if you do everything correctly, I've worked it out. That is going to be 4 newtons. Okay, so just saved it some time over here. Now you can simplify. I'll just give you a heads up. 17 ones are, 17 twos are, 13 ones are, 13 twos are, and then you can further subtract and you will get 4 newtons. Okay, now let's do the exact same thing for the resultant in the y direction, which means all the forces acting upwards minus all the forces acting downwards. Okay, this shouldn't be that big of a problem since we just have two forces. So 34 cos theta minus 26 cos alpha. So the resultant in the y direction will be 34 cos theta minus 26 cos alpha. Okay, so 34 cos theta means 34 into 15 upon 17 minus 26 cos alpha means into 12 upon 13. And again, if you do this correctly, you will get 6 newtons. So the resultant in the y direction is 6 newtons. Resultant in the x direction is 4 newtons. Okay, now we need to find out the overall resultant, okay, and the direction. So again, since they're both positive, that means you have one force which is acting rightwards. That's the horizontal force. And the vertical force is acting upwards. You make a nice 90-degree triangle out of it. So here is 4. Here is 6, again, not drawn to scale. So that means you are going to find out the resultant, which we have to, and this direction right here. Okay, so in order to find out the resultant, that should be a no-brainer. 4 squared plus 6 squared. So that means r is equals to, inside the square root, of course, square root of 36 plus 16, which is 52. Okay, now you can further simplify 52 in third form and write it like that. And that is 2 under root 13 newtons. Now, what about the direction? Now, notice that this horizontal force of 4 newtons is actually in line with the 30 Newton force. Why? Because they're both horizontal. So that means this direction that you will find out will actually be the angle formed from the 30 Newton force. Okay, so tan is what we're going to use. Tan theta is equals to opposite upon adjacent. So let's take the inverse. Tan inverse of 6 upon 4. So we're looking at 56.3 degrees from the 30 Newton force. And what about the direction? It is anti-clockwise. So in fact, I should have written anti-clockwise first. 56.3 degrees anti-clockwise from the 30 Newton force. And there you go. That's it. That's the answer. So this is how, these are two example questions of category 2. That is when you have 3 or more forces. Next, let's take a look at 3 or more forces and what happens when they're in equilibrium. All right, so here we are. This again is a past paper question. Now remember, this category is where you have 3 or more forces that are in equilibrium. Now, again, not a lot will change over here. Just one simple concept that we have to remember, and that is what happens, if you remember from the first video, I guess, what happens when an object is in equilibrium, the forces are in balance. So that means all the upward forces cancel out the downward forces, and just like that, all the rightward forces cancel out the leftward forces. Okay, so this is from May, June 2019, paper 4, variant 1. I don't know if I mentioned that already, but let's get straight into it. So it says here, first let's read the entire question. Given that tan alpha equals to 12 upon 5, tan theta equals to 4 upon 3, show that the coplanar forces in the diagram, shown in the diagram, are in equilibrium. Okay, so this is a show question, so that means we don't really have to find anything. We just need to prove that yes, they are in equilibrium. Now, how will I do that? It's very simple. The leftward forces should be equal to the rightward forces, or you can say that the resultant is equal to 0. That means if you add all the forces, your answer should be equal to 0. Now, I'll show you what I mean by that. It's fairly simple. So first things first, however, that is if tan alpha equals to 12 upon 5, we need to find out, because again, think a couple of steps ahead. You will need sine alpha, and just like that, you might even need cos alpha. In fact, you will for sure need cos alpha as well. So if tan alpha equals to 12 upon 5, that means we are looking at a triangle such that the opposite side is 12 and the adjacent side is 5. Again, no need to draw it to scale. Again, this by no means looks like the opposite side is 12 and the adjacent is 5, but it'll do the job for us. The hypotenuse is going to be 13 using Pythagoras theorem. So using this, you can work out sine alpha, which is going to be equal to opposite over hypotenuse. And using this, you can also work out cos alpha, which is going to be adjacent over hypotenuse. That's 5 upon 13. And just like that, you are told that tan theta equals to 4 upon 3. That means if you make a right angle triangle, the opposite side will be 4, the adjacent will be 3. So here's the opposite side, and here's the adjacent side, which is 3, and here's theta. Again, using Pythagoras theorem, you will have the hypotenuse side, which is 5. So if we want to find out sine theta, that's going to be opposite over hypotenuse, so that's 4 upon 5. And just like that, if you want to find out cos theta, that's going to be adjacent over hypotenuse, so that's going to be 3 upon 5. Okay, now, so because it says that we need to show that they're in equilibrium, that means we need to show that, yeah, here it is. We need to show that the resultant in the x direction is equal to 0. And not only that, we need to show that the resultant in the y direction is also equal to 0. Okay, so what does that mean? That means that if you sum up all the forces, you will have 0 as your answer, or you can show it like this, that all the forces acting in the rightwards direction minus all the forces acting in the leftwards direction is equal to 0. And at the same time, all the forces acting upwards minus the forces acting downwards is equal to 0. Again, there are like a whole bunch of ways of looking at it, and here is 2 of them. Okay, so let's calculate all the forces that are acting upwards. Okay, that's the approach that I'm going to take, all the forces acting upwards, and from that we will subtract all the forces acting downwards. So let's start breaking down this 50 Newton force. So again, this will have a horizontal component and a vertical component. So the vertical component is going to be 50 sine theta because it's the opposite side, and the horizontal component is going to be 50 cos theta because it's the adjacent side. Now let's break down this 78 Newton force. So this will also have a horizontal and a vertical component, obviously. The vertical component is going to be 78 sine alpha. The horizontal component is going to be 78 cos alpha. Yep, so far so good. Okay, now, so theoretically, all the forces acting upwards, let's make a note of that, 78 sine alpha. In fact, first let's write this down, 78. So we're going with vertical forces first, 78 sine alpha plus 50 sine theta plus 50 sine theta should be equal to the force that's acting downwards, or you can think of it this way, that minus the force that's acting downwards, which is just the 112 Newton force, should be equal to 0. Again, remember, just decide what to do and then stick to it. Okay, so 78 sine alpha means 78 into 12 upon 13 plus 50 sine theta means 50 into 4 upon 5 minus 112 equals to 0. Okay, so let's work this out. 78 into 12 divided by 13. This is 72 plus 50 into 4 divided by 5. So that's 40 minus 112 equals to 0. 72 plus 40 is in fact 112 minus 112 equals to 0. So 0 equals to 0, and there you go. Hence, now not proved entirely, but hence, you can say that the resultant in the y direction is equal to 0. Okay, so that is what you've shown so far. Now let's also talk about the horizontal resultant. Okay, So we have 50 cos theta and 78 cos alpha. So let's write that down. 50 cos theta minus 78 cos alpha technically should be equal to 0. Let me make sure that I've written it correctly. Yep, so far so good. So 50 cos theta means 50 into 3 upon 5. 78 cos alpha means 78 into 5 upon 13. So looks good. 5 ones are, 5 tens are. So 10 into 3 is 30. Okay, for this I'll need a calculator. 78 into 5 divided by 13. So that's also 30. So that's equal to 0. 0 equals to 0. So that means hence resultant in the x direction is equal to 0. And there you go. That's it. That's through this we have proved that yes, all these forces, all these coplanar forces shown in the diagram are in fact in equilibrium. Okay. So that was one example. Let's do another example. This is quite a comprehensive example. And the reason why I've chosen this example is because you have 4 forces over here. Now, although you don't need to break down all 4 of them, it's just the 3 forces you need to break down. But still, this question is very important because it will sort of prepare you as to how you need to be systematic with your working. Okay. Now, I have this approach where I sort of like to make a table. Okay. And I only do this when you have like a whole bunch of forces acting. Okay. So in this table, what I'll do is, let me show you what I'm talking about. So basically, we have one column for the forces. So here are the forces, okay? And we'll have one column for the horizontal forces, okay? And how will we distinguish between left and right? Rightwards is positive, obviously, and leftwards is negative. In fact, let me make this slightly neater. So, yeah. And we have another column where we will write down all the forces that are acting vertically. Again, how will we distinguish between up and down? Upwards will be positive, downwards will be negative. Okay. Now, what this does is this just makes the whole approach systematic. Okay. Now, let's start with this 8 Newton force. Okay. So I'll write down 8 over here. Okay. Now, if you break down the 8 Newton force, you know very well that both its components, the horizontal and the vertical, they will both be positive. Okay, so what I like to do is I just like to put a plus sign over here so that I know that eventually it's going to be positive. Okay, so that even if I forget, I've written it beforehand just so that I don't forget basically. Okay, so this is going to be 8 sine 30 and this is going to be 8 cos 30. Okay, now by the way, I don't think I read the question, so let me do that right now. You have 4 forces over here that act at a point in the direction shown in the diagram. The system is in equilibrium. You need to find P and theta. Okay, so eyes on the prize, P and theta. Okay, so it's a fairly lengthy question, so just bear with me. Now, 8 cos 30. Let me write that again. 8 cos 30 is the horizontal component, whereas 8 sine 30 is the vertical component. Okay. Now, then we have, now you can sort of number these forces as well. Okay. 1, 2, 3, 4. Okay. Then let's talk about the second force, which is the 12 Newton force. Now, the good thing about this 12 Newton forces is that it just has a horizontal component, which is itself, okay, because it's not acting at an angle, it's acting horizontally. So that's it. Okay. There's nothing to worry about. Now, as far as the vertical component goes, it's equal to 0. Okay. Then let's talk about the 10 Newton force, which is force number 3. Now, again, if you sort of plan a couple of steps ahead, you know that it will have a leftwards component and a downward component when you break it down. So that means both of them will be negative. Okay. Now let's look at the actual value of it. So this is going to be, this component right here is going to be 10 cos 45. So let's write that down. 10 cos 45. And this is going to be 10 sine 45. So 10 sine 45. And again, why do we have a minus sign with them? That's because they're both acting leftwards and downwards. Okay. Then let's talk about force number 4, which is P newtons. And this also will have a leftwards component and an upwards component. So again, be careful, write a minus sign over here, but not over here. Okay, because the vertical component is acting upwards. Now, as far as the horizontal component is concerned, that's going to be minus p sine, sorry, not sine, minus p cos theta. And as far as the vertical component is concerned, that is going to be p sine theta. Yeah, so far so good. Okay, now because the system is in equilibrium, that means sum of all the forces, sum of all the horizontal forces will be equal to 0, sum of all the vertical forces will be equal to 0. Or in other words, the forces that are acting leftwards will be equal to the force that's acting downwards. Okay, so again, a whole bunch of ways of looking at it. It's up to you, whatever approach you decide to go forward with. So I will go with this, that all the forces acting rightwards should be equal to all the forces that are acting leftwards. And remember, how will we distinguish which one's acting rightwards and which one's acting leftwards? By the sign. Okay, so the two forces that are acting rightwards are 8 cos 30 plus 12, and the two forces that are acting leftwards are basically 10 cos 45 plus p cos theta. Now you may be wondering, why did I not write it with the minus sign? Now remember, the minus sign was only to help us identify the direction. Okay, so positive meant rightwards and negative meant leftwards. So that's why we've ignored the minus sign. Or what you could have done was you could have added all these up with their signs as it is and equated that to 0, which would have led to exactly the same thing. Okay, now we'll come back to this equation later, or if you want, when you solve questions like these enough, you will notice that they have a particular pattern, so you will know exactly what to do, and that is, it's best that you make p the subject. Okay, now why p? I'll explain in a minute. So let me do that first. 8 cos 30 plus 12 minus 10 cos 45, and at the same time, if you divide it by cos theta, this is what we have p as. Okay, now why have I made p the subject? Because remember, there are two unknowns, p and theta. We have to find p and theta both. Now, making theta the subject meant that we would have to take cos inverse, because I would have had to get rid of this cos, right? That means taking inverse. But that is not a good idea, because that would make things complicated. That is why it's best that you make the force that you have the subject. Okay, now things will make more sense if you just bear with me and if you form the other equation. So this is one equation, and clearly it's not sufficient for us to find out the value of p. Okay, now for the other equation, remember the forces acting upwards are equal to all the forces that are acting downwards. Now, how many forces do we have that are acting upwards? Just this one here. In fact, we have two forces acting upwards. So that means 8 sine 30 plus p sine theta is equal to the one force that's acting downwards, and that is 10 sine 45. Now, you may be wondering that why am I keeping it all in terms of sine and cos? That's because I don't want to deal with a lot of decimals already. Okay, so we'll work it out at the very end. Okay, so if I make p the subject over here, so we have 10 sine 45 minus 8 sine 30 divided by sine theta. Okay, here's the second equation. Now, next thing we're going to do is we're going to equate both of them. Okay, so that means, let me just save a bit of time and copy this, paste it here, and at the same time copy this, since this is also p, and paste it over here. Okay, now this might seem as if it's unsolvable, okay, but it's not. For this, in order to make sure that you're able to solve this, you have to remember the identity, which is sine theta upon cos theta is equals to tan theta. Now, if you're an AdMath student, this is something you would know. If not, just remember that this is an identity, which is sine theta plus cos theta equals to tan theta. And there's another identity we might have to use, which is sine squared theta plus cos squared theta equals to 1. Not in this, but in some questions. Okay, so my objective right now is to somehow get sine theta above cos theta, and that means swapping places of these two, this 8 cos 30 plus 12 minus 10 cos 45 and sine theta, which means that we will have sine theta upon cos theta to be equal to 10 sine 45 minus 8 sine 30, and all of this divided by 8 cos 30 plus 12 minus 10 cos 45. Now, this is equal to tan theta. Okay, so tan theta is equals to this. So again, I'm just going to save some time and copy paste it. But now we're going to use a calculator to figure this out. So 10 sine 45, close the bracket, minus 8 sine 30, close the bracket, divided by 8 cos 30, plus 12 minus 10 cos 45. Just make sure that you reset your calculator, okay, and then take the tan inverse of it. So we have theta, which is equal to, let me make sure, yep, that's the correct answer, 14.5. So theta is equals to 14.5 degrees. But that's not the end of the question. We still have to find out the value of P, for which you can simply use, since they're both equal to P, so it's up to you whatever you want to use. So I'm going to use this equation right here. Okay, I don't know why I crossed that out. Yeah, so let me copy this, paste it here. There you go. And in place of theta, I will plug in 14.5. Okay, so there you go. 10 sine 45 minus 8 sine 30, close the bracket. Otherwise, you'll end up with a syntax error. Divided by sine theta. Now, it's preferable that you use the answer key so you don't have to worry about using the rounded off value. So P is equals to 12.24, which we will round off to 12.2 newtons. Because P is a force, so the unit is going to be newtons. And there you go. That's it. 6 more questions solved. So yeah, I hope you've understood the concepts that I've used in this question. And also remember to do it in a systematic way so that you're clear about what you're doing, because notice that you'll have a lot of sine theta, cos theta, and all of that to deal with. So you have to make sure that you don't get lost in your own working. So yeah, that's it. That's it for this video. I plan on doing a live stream on this where I solve like plenty of questions together. We solve plenty of questions together, in fact. So yeah, but that's it for now. That's it for this video. I'll see you guys in the next one. Until then, take care. Bye-bye.